In 4.2, we're going to be learning about the characteristics of the quadratic graph. First, we want to remember that a quadratic written in standard form is ax squared plus bx plus c. Now, we want to make sure that our function is in standard form before we declare what a, b, and c are. So let's look at our first equation. If you notice, the x squared is not first. So we're going to want to pick it up with a sign to its left and put it first in our order of our quadratic. So you can see I've rearranged it so that the square is first, the x is by itself in the middle, and then I have a constant at the end. Once I have it in ax squared plus bx plus c format, I can declare what a, b, and c are. A is the number in front of x squared. B is the number, the coefficient in front of the x. The coefficient is -1. C is the constant by itself. Remember that A, B, and C can have negative or positive values, and they can be decimals, fractions, they can be whole numbers. So we have A, B, and C. Our problem asks if the parabola is either concave up, concave down, points down. Now there's an easy way to remember this. If A is positive, then it's going to be concave up, and positive people like to smile. If A is negative, then it's going to point down, and negative people look sad. So let's look at our A. Our A is a 4. 4 is positive, it's greater than 0, so we're going to be concave up. Our next problem is written in vertex form. When we're in vertex form, our function is equal to a times the quantity x minus h all squared plus k. And we can read the vertex off as hk. But our problem asks if the parabola is concave up or down. So a is the coefficient in front of the x minus h. So in our a will equal -1. And what's interesting is if you expanded this out, the a stays the same whether it's in standard form or in vertex form. So since it's -1, our rules are also the same. If a is positive, greater than 0, it's going to open upward. And if a is negative, less than 0, it's going to open downward. So since ours is a is equal to -1, it's a negative number, so it's going to open downward. Next problem asks to state whether the function opens wider or narrower than a basic function. And they don't want us to use a graphing calculator. So we know that if our problem is in standard form, then we can find A. So let's look at our first problem. We see in this problem that our B and our C are both 0. That's okay. Our A is 8/7. We need to look at our A. If the absolute value of our A is greater than 1, then it's going to be narrower than the basic graph. And we learned that already in our previous chapter. We said that if A is greater than 1, then we will have a vertical stretch, right? We did that if we said the absolute value of A is greater than 1. We said that when we were talking about transformations, right? So if you think about that, what that means is if you have a function, you grab those the two ends of the y-axis and stretched it, you'd see that the parabola would get more narrow. It would be vertically stretched. In this chapter, they just use different words. So we know vertical stretching makes it narrower. So we'd say it's narrower than a basic function. Let's look at our second problem. This time we're out of order. And remember, if they try to trick you this way, don't let them trick you. Pick up the entire term, including the sign, to its left. Now we can see that A in this problem is -1/2. B is 0, and C is +3. But all we're caring about for narrower and wider is our A, okay? Since A is less than 1, we're going to say that we would have, in our last section, we would have said we have a vertical compression. So in this section, we're going to say wider than the basic function. Our next problem asks us to find the y-intercept of the function without using the graphing calculator. We know that at the y-intercept, x is equal to 0. So all we need to do is replace x with 0. So we know 2 times 25 is 50, minus 2 is 48. So our y-intercept is 48. Or you could put it in as an order pair, 0, 48. Both are correct. Next problem asks for the vertex. So for the vertex, we have to know that the x-coordinate of the vertex is given by negative b over 2. The y-coordinate is the function where x is negative b over 2a. The first thing we need to do is decide what a, b, and c are. Always check to make sure that your function is written in standard form, ax squared plus bx plus c. You can see mine is written that way. So I'll say a is equal to negative 3, b is equal to negative 18, and c is equal to 7. Once I know what a, b, and c are, I can write that my x-coordinate is equal to negative b over 2a, and I can evaluate it for a and b. So a is equal to negative 3, and b is equal to negative 18. Notice I use a parentheses to replace my variable before I put in my number. This will help me eliminate mistakes with positives and negatives. So I get my x value as negative 3. Now I need my y value. To get my y value, I take my function and I evaluate it at negative 3. So my vertex will be negative 3, 34. It also asks me whether it is a minimum or a maximum. This is not hard at all. We look at a. We know that a is negative. If it's negative, it's going to open downward. Our vertex then has to be a maximum because it's at the top of the hill. Our next question asks us to find the equation of the axis of symmetry. The equation for the axis of symmetry is always the same. The axis of symmetry is going to be x is equal to h, where h is our x-coordinate of our vertex. So for us, it will be x is equal to negative 3. C asks me to state whether the graph of the function opens wider or narrower than the graph of the basic parabola, y is equal to x squared. So once again, we want to look at that a. A is equal to negative 3. Since the absolute value of negative 3 is greater than 1, we know that we are going to vertically stretch, which creates a narrower parabola. Our next question also asks us to find the vertex, but this time our equation is written in vertex form. Vertex form says a times the quantity x minus h all squared plus k is equal to y. So if we want to find our vertex, we're going to look for hk. Come over here. We see that this is h and this is k. Now notice in our vertex form it's a minus. So I always say h lies. So whatever you see, if you see a plus 3, it's really a negative 3/7. So h lies and k tells the truth. So whatever you see with k is telling the truth. So my vertex is negative 3/7, negative 2. Is it a maximum or a minimum? The way I can tell this is I look at a. A is equal to negative 3/8. Since it's negative, we know that it's going to be going down, pointing down. So our vertex would have to be at the top, so it's going to be a maximum. B asks me for the equation for the axis of symmetry. Our axis of symmetry will always be x is equal to h. So in our case, it'll be x is equal to negative 3/7. State whether the graph of the function opens wider or narrower. So we look at a again. A is equal to negative 3/8. Since the absolute value is greater or is less than 1 in this case, Since it's less than 1, we know it's going to be vertically compressed. So it's going to be wider than our basic function. Our next question asks us to use our graphing calculator to find first the X-intercepts. So let's get our graphing calculators out. So first, I'm going to enter in my equation in my grapher. Now, if I graph this, I can see that I have two X-intercepts. I'm going to use the intersect method. In the intersect method, I have to put y2 is equal to 0. And now I'm going to hit second, trace, 5, and then I hit enter 3 times. And it tells me that my right X-intercept will be 3.8272474. So let's round this to 2 decimals and make it 3.83. Let's find our left X-intercept. To do this, we repeat this procedure, second, trace, 5. But before we hit the enter 3 times, we're going to move our little cursor using the left or right arrow key closer to the 0 I want to find. And then I just hit enter, 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 and it will find the left intersection at negative 7.58. So these are my two X-intercepts. Next, we're going to find the Y-intercept. We can use our calculator again to find this. So let's just try it. So let's say second table. We want to find when the X is equal to 0, what the Y will be. And you can see that when X is equal to 0, Y is equal to 11.6. You can write it as an ordered pair or just a number. Next, we're going to want to find the vertex. To find the vertex on your calculator, you're going to want to use second, trace, and then either the minimum or maximum of key. So we want to look at the A here. Our A is negative 0.4. Since it's a negative A, we know it's going to point down. Think of a sad person. So it's going to be a maximum. So I'm going to say 4. When I do this, all I needed to hit is anywhere on the left side of the vertex. And then I use the right or left arrow to move to the right side of my vertex, anywhere to my right of my vertex, and hit enter. So you can see the 2 arrows here are showing you, is the vertex between those 2? And you're saying yes. We don't guess, we can just hit enter. Negative 1.913. And will this be a maximum or minimum? We already said that since A is less than 0, it's going to be pointing down. So we're going to have a maximum. Okay, part D asks for the increasing and decreasing intervals. So let's just do a little quick sketch of what this looks like. Actually, we'll use our graphing calculator. We can see that we're going uphill to the vertex and then downhill to the vertex. So we know that we're going to be going increasing from negative infinity to negative 1.9. Now, we're neither increasing nor decreasing at the endpoint, the mountaintop or the valley. And we're going to be decreasing on the other side. Our last problem asks us to write the equation for the graph shown. Let's see what we can pick off. Now, I don't know what the X-intercepts are. If you look at it closely, they're not exactly at a grid mark, so I can't use them. But I can clearly see my vertex. So I went ahead and graphed that point as -7, -48. So I know the vertex, and I want to see, is there one more point that I can get that I can clearly read that's a grid mark? Well, I can see that here's one right there. That is clearly -5, -40. When I have a vertex and a point, I can write the equation for the line. So what I'm going to do is I'm going to replace my vertex for the H and the K. So my h is -7 and my k is -48. Notice I'm very careful with replacing the variable with parentheses and then putting it in so I don't mess up the negatives and the positives. So far I've only entered in my h and my k. I also, though, now have an x and a y because I have a point. So let's substitute them in for my x and my y. So my x is -5 and my y is -40. So now the only thing I'm missing is a, so I can solve for a. So let's clean this up. So this is going to be -5 minus, or that's going to be +7 when we say a negative times a minus times a negative squared. Minus 48 is -40. So 7 minus 5 is 2, squared is 4. I'm going to add 48 to both sides and divide by 4. And I get a is equal to 2. So now I can write my equation. I know that's 2x minus -7 squared plus -48. So if you notice, I replace my h, my k, and my a. I leave my x and my y, and I'll get 2 times x plus 7 squared minus 48.